Okay, our last panel today relates to the training of industry personnel. The question for the panel is, what type of training and certification should be required for key industry personnel? The moderator is Mark Rubin. Mark has served as the Executive Director of the Society of Petroleum Engineers for over 10 years, is responsible for SPE's domestic and international operations. Prior to joining SPE, Mark served as the Upstream General Manager for the American Petroleum Institute. Mark has a bachelor's degree in petroleum engineering from Texas A&M and an MBA from SMU. Mark?
Thank you. And thank you to everybody who stayed around for the last panel, panel number 5. We're the last on the list, but the subject is incredibly important. We can have all the equipment, the monitoring systems in the world, but we have got to have good, well-trained people in order to use those systems that we've created. We have 5 speakers, kind of a diverse set of speakers, and the order we're going to go in is we're going to have Dr. Winter first, then Mark Denkowski, Ford Brett, Joe Savoy, and then Ken DePaul speak. And after that, we'll have open it up to questions that anybody may have. So first, let me introduce Dr. Donald Winter. Dr. Winter is a professor of engineering practice at the University of Michigan. He served as the 74th Secretary of the Navy from January 2006 through March 2009. And before that, he held multiple positions in the aerospace and defense industry as a systems engineer, program manager, and corporate executives. Dr. Winter received his doctorate in physics from the University of Michigan, and he was elected a member of the National Academy of Engineering in 2002. And he has chaired the NAE committee responsible for investigating the Deepwater Horizon incident for the Secretary of the Interior. Don?
Thank you very much, and good afternoon. I will forego the use of PowerPoint this afternoon, if that's okay with everybody. As you perhaps heard, I am a systems engineer, not a ViewGraph engineer. I do want to start out the presentation with a few comments about the committee that we established within the National Academy of Engineering, the National Research Council, to support the DOI in terms of the investigation of the causes of the Deepwater Horizon incident. In particular, I'd like to note that we had 15 members on the committee with a very broad spectrum of backgrounds and expertise that spanned pretty much everything from geophysics and petroleum engineering to safety systems and organizational behavior. The objective of that structure, that staffing, if you will, was to try to ensure that we had the wherewithal and the expertise necessary to be able to identify not only the direct causes of the loss of well control, but also to be able to deal with the contributing and systemic factors as well. The committee concluded its work late last year. The final report has been published. If you haven't seen it, this is what it looks like. You can get copies of this from the National Academy of Engineering. Oh, by the way, if you want to save a few bucks, you can go on the website and download a PDF copy for free. It's a good deal. Earlier today, you heard from Roger McCarthy regarding the committee's assessment of the BOP design. And there's quite a bit more than Roger was able to address within the limited time that he had. And you can find the additional comments in the final report. My comments this afternoon are going to focus on the committee's assessment of training shortfalls as evidenced by the response of personnel on board the Deepwater Horizon. Much of this is documented in Chapter 4 of the final report. And I will note that we took a very broad perspective in taking a look at the problem, in particular examining the preparedness for emergency response at sea, not just the issues of well control. I will also note that our findings and recommendations were influenced, if you will, by the Navy backgrounds represented on the panel, which included not only myself, but Admirals Eccles and Giambastiani. I'll go through a very brief recap of some of the principal findings and recommendations and try to put them into perspective. Perhaps the principal finding that we had with regard to the adequacy or inadequacy of training is noted as 4.3, and I'll just read the simple finding here. It says that alarm and indication systems, procedures, and training were insufficient to ensure timely and effective actions to prevent the explosions or respond to save the rig. And I'll say a little more later on relative to the issues associated with timely response. The report goes on, and the committee identified a number of what are termed sub-findings to substantiate this principal finding. And I'll just identify a few of those. We noted that the crew was ill-prepared for the scale of the disaster. We assessed that the watch officers were not adequately trained. We noted that the emergency procedures were inadequate to minimize damage and loss of life. We noted limited crew participation in training and exercises, limited realism in training scenarios, and a lack of cross-rate training. Now, as I noted before, a lot of the perspective here, including some of the wordings, represent a Navy perspective. And that perspective has been significantly influenced by events such as the tragedy that occurred on the USS Forrestal in 1967 off the coast of Vietnam. At that time, Forrestal was an aircraft carrier. One of the aircraft on the flight deck of the Forrestal inadvertently released a rocket before it took off. That rocket penetrated another aircraft. Fuel was spilled on the deck and was ignited by the rocket exhaust. And the net was a major conflagration, which led to the loss of life of 137 sailors, one of the most significant tragedies of that time. It really did cause the Navy to re-examine its preparation for major emergencies at sea, and led to a decision that all sailors needed to be trained, at least to a basic level, in such matters as damage control, medical assistance, and evacuations. Fundamentally, major emergencies affect all on board, and they require the assistance of all on board to mitigate the damage and to be able to save both lives and the vessel. One of the things that's come out of multiple examinations over many years is the importance of timely response. We found over many examples that getting water on a fire quickly, in many cases, is even more important than exactly how you get the water on there. Getting emergency medical assistance to an individual is often more important than getting a high degree of medical knowledge to the scene. Getting the very quick responses is absolutely critical, and the only way that you can do that is to ensure that the totality of the crew has basic training and not simply to rely on specialists. Nowadays, the training for all sailors starts in boot camp, Great Lakes Training Center. The graduation exercise for Great Lakes nowadays is something called Battle Stations 21. I don't know if any of you have seen it or have seen the show that was done by CNN on the events there. But it basically is an emulation of the tragedy on board the USS Cole. The sailors go onto a near real-size ship that has the ability to simulate much of what transpired that evening. By the way, the tragedy typically starts at about 05 or 5 o'clock in the morning to make sure that everybody is afforded the full sense of realism. It is a truly realistic simulation, which includes explosions, gas-fed fires, compartment flooding, serious injuries with dummies that are fixed up to simulate serious injuries, including bleeding and moaning and groaning. The training that they receive in boot camp is all tested on that one occasion, and it provides them with an experience that they can carry through to subsequent schoolhouses and to activities on board ship. I'll also note, by the way, that perhaps a similar assessment might be worthwhile in the cruise ship industry, in particular after we've seen the Costa Concordia evidence many of the same problems that were identified 100 years ago in the evaluation of the Titanic loss. Recommendations. We had a series of recommendations that are all, again, included in our final report. I won't go through all of them here, but just try to highlight a few of the major aspects that came out of the committee relative to Deepwater Horizon, albeit with the backgrounds I noted. We identified the need for realistic and effective training, formal qualifications with periodic re-examinations. We identified the need for major drills at sea, the need to have all personnel qualified on damage control and personnel evacuations, and the need to re-examine qualification requirements for key positions such as the OIM. We also addressed issues of certification, including the need for senior corporate officials to act as certification authority, the use of existing safety programs as models for such certifications. Perhaps not surprisingly, we suggested the SubSafe program as perhaps one viable model there. And we also recommended the use of annual reviews by an independent and competent authority. Now, in closing, I will note that we have seen how properly implemented safety systems can significantly influence the safety of a very dangerous industry. After the loss of the submarine Thresher almost 50 years ago, the Navy implemented what is now known as the SubSafe program. I will also note that that implementation took less than 1 year after the loss of the Thresher. Since that program has been implemented, no U.S. Navy submarine has been lost. No U.S. Navy SubSafe certified submarine has been lost in the 50 years since then. In the 50 years prior to Thresher, as a point of comparison, we lost on average one submarine every 3 years due to non-combat related causes. That change in safety is arguably the direct result of the implementation of the SubSafe program. This industry can do similar good things, and we do believe it should. I thank you very much and look forward to the opportunity to answer any questions that you might have.
Thank you. Our next speaker is Mark Denkowski. Mark is the Vice President for Accreditation and Certification for the International Association of Drilling Contractors. At IEDC, Mark directs all operations of their accreditation programs. He has over 30 years of industry experience, having worked offshore in Southeast Asia, the Middle East, West Africa. His career also includes training in HR positions for Global Santa Fe, Transocean, and Frontier Drilling. While at Frontier, he was a member of the IEDC Training Committee and the chairman of the IEDC Competency Assurance Panel. Mark has a BS degree in Earth and Mineral Science from Penn State University.
Good afternoon. I want to thank BSEE for the opportunity to present this today. Unfortunately, I do have a PowerPoint, and kind of starts with the slide I like to see because my name's up there. But last week, IDC hosted a LAN conference, which was very successful. And as part of that LAN conference, one of the presenters had a slide that was titled Challenges and Opportunities. And on the slide were various pieces of equipment to include BOPs and roads and other issues. And in the middle of the slide was a bullet point of people and training. Now, I would contend you should move that up to the top of the list. You should bold it and underline it, because the biggest challenge I think we have is finding qualified people, train those people to be prepared for their first day of work, being prepared for promotions, being prepared to supervise once they've been promoted, and being prepared to work in teams. But if we do that all correctly, that's also our greatest opportunity. It's our greatest opportunity to improve our industry overall and as a whole, is our people. We have to prepare them correctly. One of the components of that training I want to talk about today is WellCap rig pass training. WellCap was originally conceived and born out of an industry request to create a forum where all segments of the industry, both operators, contractors, and service companies, can talk and come up with a standard that can be applied worldwide. Back in 1995, that project started with a work group, essentially. That work group eventually became the Well Control Committee and its various subcommittees for curriculums and other issues. Over the next several years, the program was built and implemented and brought out worldwide. And in 2002, the OOC officially endorsed the WellCap well control training. And today we have over 158 training providers that we accredit worldwide, and the numbers are growing. The program is based on having instructional quality. It's all about doing it the right way and consistently doing it the right way. We look very heavily at course content standardization. Our curriculums are pretty rigid, and people must comply with those when they design their courses. We look very carefully at how people deliver the course, the materials they use. Everything is vetted through technical experts. And we also spend a lot of time vetting all of the instructors, making sure that they are not only qualified, but that they continue to do their education, that they continue to be recertified by attending not the schools they teach at, but well-controlled training at other schools so they see how everybody else does the training as well. We're going to make sure that the instructors are the best and the strongest in the industry. Of course, we're very concerned about student assessments and doing it the proper way. We're currently doing a lot of work to try and improve the assessments, both in written test form and in simulation. And the last component is making sure that the administration of those programs and that the quality assurance of those particular schools is as good as it can be. The programs haven't been dormant since 1995. Just a couple line items of major things that have happened. 1997, the workover and completion curriculums were developed. In 2001, coiled tubing, snubbing, wireline, and underbalance curriculums were developed. 2002, subsea guidelines were introduced. Also in 2002, the original curriculum of the driller curriculum was revised. And I can go down this long list of things that have happened. Since 95, 51 bulletins of change have been issued to training providers to improve the program. So it's a constant work in progress, and our committees are very dedicated and work very hard to keep this as current as possible. We're also ISO certified. We believe that if we're going to go out and ask people to allow us to audit their programs, that we should be audited ourselves, so we are ISO certified. The courses that are offered, as I mentioned, are a drilling curriculum, workover and completion. Those two can be combined. A coiled tubing course, snubbing, wireline, and underbalance. And for the drilling and workover, there are 4 different levels: introductory, fundamental, supervisory, and WellCap Plus. WellCap Plus is one of the newer things that, one of the accreditations that we offer. And essentially, WellCap Plus is a supervisor level training course that is scenario based. People break up in teams. It's meant to be able to substitute every other cycle of accreditation. And the idea is that students break up into teams and solve real life well control scenarios on paper There are some people out there that actually use simulation to do this. But they get to practice the real, they get to decide how they would have handled a well-controlled situation and then compare it to the real event. And at the end of the day, learn if they did it right, if they did it wrong, and how best to do it. It's a great way to learn. We also have surface and subsea stack qualifications. The subsea right now is only available for the drilling and workover, but the subsea components for the well servicing side, the coil tubing, snubbing, and whatnot, is under development. The recommended levels, and this is always a bone of contention, is who should go to what level, but we recommend that the introductory level only be for floormen, derrickmen, fundamental level for derrick hands, assistant driller and drillers, and you'll see a little overlap here, but supervisor would be for drillers, tool pushers, superintendents, drilling foremen, and obviously the WellCap Plus should be for your most senior staff, but not just the senior staff, but also operations personnel, operator personnel, and anybody that's involved in well control should be involved in these scenario drills. Looking forward, as I said, WellCap is something that's always in development and always being reviewed for the best way to do it. And recently we did organize a new advisory panel. That panel is going to look at curriculum structure and content. We're going to look at learning objectives to take it, you can put PowerPoints up like I have here, but it's much more powerful when you turn it into learning, not just PowerPoints or can you finish a test or complete a test. So we're doing a lot of work in trying to make sure that there's learning and retention. A lot of the issues with well-controlled training and any training is retention, especially with the cycle of every other year actually sitting through the course. We will be looking at frequency. Is 2 years the right frequency? Is every 3 years with interim continuing education the right frequency? Should people of certain disciplines do some training every time they hit the rig? We're looking at all these different aspects. And another project that we're working on is our Knowledge, Skills, and Abilities project. About 10 years ago, there were a dozen positions, rig-based positions, where competencies, minimum base competencies were developed. Again, at the request of our members and regulatory bodies, we've started a new project to completely rewrite these competencies, but for all rig-based positions and beyond. And this is critical for the work that the advisory panel is doing as well, because these competencies will tie right back into the WellCap training. We will be starting with positions that do have well control responsibilities. And our aim is to build a global set of minimum competencies that people can measure themselves against. Add things such as different methodologies for measuring that. It's not really a competency assurance program, which we have accreditations for, but it's the guideline on how to get there. We're also looking at, beyond this, we're looking at other things such as certifications for different positions on the rig, such as possibly subsea engineers, and a lot of other issues that our members are bringing forward. That's the quick down and dirty about WellCap. So thank you very much. I look forward to any questions at the end of the presentation.
Thank you. Our third speaker is Ford Brett. Ford is the managing director of PetroSkills, the world's largest petroleum training organization. Prior to joining PetroSkills, Ford worked for Amoco on drilling projects in the Bering Sea, North Slope of Alaska, Gulf of Mexico, and offshore Trinidad and in Wyoming. Ford has been granted over 30 U.S. and international patents and authored or co-authored over 30 technical publications. He has served on the board of directors of the Society of Petroleum Engineers, and in 2010 served on the U.S. Department of Interior's Macondo 30-day peer review panel. He holds a BS in Mechanical Engineering and Physics from Duke University, an MSc from Stanford University, and an MBA from Oklahoma State University. Ford?
Thank you. First of all, I'd like to thank Bessie for the opportunity to come present, and I'm going to give you two answers to the question of what type of training and certification be required for key industry personnel. The two answers I'm going to give you is a short answer and a 90-second answer, and then I'm going to try to do a 9-minute answer. And I don't know that anyone would be interested, but actually you could have a 9-day answer. You could have a 9-month answer to that question, but we'll just see how the 90-second and 9-minute attempt goes. So what type of training and certification be required for key industry personnel? The short answer is training to develop the role-specific skills necessary for full cycle well integrity and crew resource management. The well integrity should extend beyond kick control to include process safety management of casing, cementing, P&A operations, and crew resource management. And that's the physics, if you want to call it, or the engineering of what's required to have wells be safe. Crew resource management is important because it turns out that drilling a well is a team sport, and it's not just about what I know, it's about what I know and what other people know and how we work together to do that. And so that's necessary. I'll tell you some good news about this is, I think, at least according to me, you're asking me this question, I think what is needed to know here is known. It's a matter of doing it. So this is not, oh, we don't know how to do this. It's known, it's a matter of doing it. Secondly, certification. And certification that I'm going to describe here can be done, and in some cases is being done. Probably have some opportunities to improve how this works, but we need the operator to have assured competency, and I think it's important that the operator be responsible for the assuring competency because they're going to be the person responsible for doing this, and there's different types and levels of competencies I'm going to talk about. So I think that was a less than 90-second answer to the question. Coming into the 9-minute answer, first you got to ask yourself, what is certification? And I looked through the regulations, couldn't find a good answer. I just look Black's Law Dictionary, what is this? Certify means to authenticate or vouch for the thing in writing, to attest as being true or as represented. It means written assurance of official representation that some act has or has not been done, or some event occurred, or some legal formality complied with. And that kind of makes it sound like I got to get it certified. Well, there's not one, in my opinion, one certified thing that's going to happen here. We're not going to have one driving test. I passed the test, I'm ready to go. There's actually operating a safe car is beyond passing the written test. You have to do it. You have to show somebody you can do it. And in fact, if you're talking about a safe car, it determines about, what's the air in your tires, what are the brakes, and so there's a lot that goes on to it besides just passing a test. And so my observation is there's not going to be one test that's going to assure competency. WellCap has a role and is important and is a key fundamental thing that we need to do and need to be worked on and improved and perhaps expanded. But if you talk about learning theory, coming back to this training thing, when you're saying you've got to certify things, well, there's two kinds of things that you can say test somebody on. They call it cognitive and affective. Cognitive is, do you know this? You can take a test, we'll sit them down, write a test, do they know it or not? This affective is, can you actually do it? Can you observe it? And of course, pilot training is an example of this where you can pass a test, but flying a plane is a completely different deal. In our business, there are things that are not unique, that are common. The elements in WellCap are a component of that, for example. And there are things that are unique, which is what is a BOP configuration on my rig, and extends beyond blowout preventers to all the other things required to keep a well safe. And similarly, when you talk about the unique effective things, it's like we got to execute this well's contingency plan, which is a bit different than, how would I circulate out a kick on theory and can I demonstrate that on a test? And so the point about this is this certification is going to be required, in my opinion, at different levels and across different dimensions, and the certification that's going to occur will not be one certifying body, but a network of certifications that's necessary. And so kind of a simplified process of this is determining the competencies, specifying the job performance standards to task condition standards, observable activities, what's required to do the work, provide learning methods and resources, and evaluate the performance. And you may need to go back and re-specify the performance standards, or provide learning resources depending upon how the performance actually occurs, and have some sort of record of achievement. So when you ask the question, what kind of training and certification is required, you need to ask, training and certification is a means, and it's a means to achieve the performance. And so we have to understand what the performance is, what's the learning required to develop that performance, and then a process that describes it in this way. And it's relatively simple, but it turns out it's going to have to be pretty detailed. And the thing about it is there is not one competency. There's a multitude of competencies required. And by the way, to kind of make matters even worse, this idea of achieving training and assessment or certification as a means to this, it's also dynamic in the sense that operations are changing. You know, what's required onshore is different from offshore. If I move offshore, I've been certified onshore. Am I certified offshore? Well, it depends on the job role, perhaps. As I move through jobs, as I'm going to be prepared for my next promotion, well, I'm currently prepared, what I do to get prepared ahead. And so it's a living kind of thing that's going to be required, where we're continuously talking about the job competencies for this particular job. You know, what is my individual ability to do what I need to do, and what's the group's ability to do that? What are the gaps? And continuously close those gaps. And again, something like this is relatively easy to describe and works pretty well, but doing it requires a detailed plan and process to achieve it. And so an example of how this is done and can be done is, first of all, addressing the cognitive component by specifically describing what does somebody need to know to do a specific task. And there can be many, many, many of these tasks that I'll describe in a second. Create the learning for that person to develop that knowledge, and it can be a self-study, a training course, watching somebody do it, and then some sort of knowledge assessment. This person actually knows what they need to know. And there might be a timeout kind of thing on this, where in fact, actually they need to continuously reassess. Then you need to have somebody actually observe you doing it in a simulation or in reality, so that you can actually have someone say, I know that they know what they need to know, and I can certify that in fact they can actually do it, and there'll be some sort of competency, record of competency achievement for one specific task, you know, task condition standard for one specific element. And then it continuously moves on and improves. There's a well-known physics to developing these appropriate training and certification required to accomplish specific tasks. It's related to the process, it's related to organization, and a little bit like Gary talked about in the last panel, where you can say, you want a BOP to work? Well, you better have the RAMs work. Well, that means the better the valves better work. That means all these different trees work out. Similarly, you can say you want to have someone know how to maintain a BOP. Well, they need to know this, they need to know this, they need to know this, kind of break down that structure. The point about it is, it's a detailed thing, but it's not an untractable, what are we going to do kind of thing. It can be done. So you have specific resources or content that describe what's required to achieve a specific set of activities, appropriate knowledge assessments and practical on-the-job capability sign-offs that someone actually has the capability of doing these. And so when you say what kind of training is required, well, it turns out that there's lots of training for lots of little things depending on where you are, and there's lots of different assessments that are required and actually observations of someone actually doing a specific task. And so while none of it is actually complex or intractable, it turns out that it's a relatively detailed task because there's lots of different things involved in our business. And so if you do that, and by the way, this is an example of one system, there are numerous practical different types of systems and processes people use to actually implement this in reality, where you have role and operation specific competencies that people need to have, skills, it's what does somebody actually need to be able to do, and then have training to develop those, and assurance methods to be able to identify whether someone actually has that role and operation specific capability, and then time or event-based recertification. Let's just check and see if you can do that again. And if you do that, you'll be able to have a detailed description of what everybody can do, and are they competent to build their job. Now, there's one important aside here, and this is a little bit of a novel thing, but I think it's very interesting. And that is a competency assessment, a test, an observation of somebody doing something is information about the capability of that group or person. In other words, it is, well, it's just information about, can that person actually close the BOP in time? Can that person calculate the proper mud weight? All the different things that would be involved in that. You can use value of information techniques, Bayesian techniques, to determine the value of that competency assessment. And based on that information. And it's based upon things like this. What's the probability a competent person will fail the test? What's the probability an incompetent person will fail the test? What's the probability a person's competent in any event? You can combine all these statistical things together, and the finding of this is very often, in fact, very often, very, very often, such techniques demonstrate very, very high economic value of assessments. The point being of this, that who wants something to go wrong in an operation? Nobody wants it. It costs money, it takes time, it's unsafe, it's just bad. This is a way to align the economic incentives with actually competency, and it's a way to demonstrate that, in fact, actually assessments turn out to be very valuable. And if you have a proper assessment, you're actually making money every time you're conducting an assessment. Anyway, that's my 9-minute answer at attempting to try to say, you know, what training and certification should be required for key industry personnel. But kind of returning to the short answer, I think we have a challenge. And well, let me tell you good news. Good news first is I don't think there is any big question or big hurdle that we need to overcome here in terms of, is this possible to do? Can we actually do this? You know, when someone talks about a 30,000 PSI stack that is going to meet all these, be available all the time, self-diagnosing and all these other things, it's kind of like, well, hey, that's a challenge. I mean, can we do that? Is that physically possible? I mean, the industry has done phenomenal things in the past decade, so I don't doubt that people will meet that. But that is kind of a challenge that you might wonder if can be done. This can actually be done. I guess the challenge is actually doing it and describing. Let's take the time to describe what's required to do these specific roles properly. How would we know they can do it? And then how do we have to be certain that people actually have the skills required to operate in the offshore safety? And so anyway, thank you very much for your time, and I'll be happy to answer questions you might have later.
Thank you. Our next presenter is Joe Savoy. Joe is Regulatory and Well Operations Manager for Wild Well Control Marine Services. He started his career at Amoco and has worked in a number of engineering and management positions at several companies, including time as VP of Operations for Offshore Energy Development Corporation and Operations Manager for Maritech Resources. Joe began his current position at Wild Well Control in 2006. He has a BS in Petroleum Engineering from the University of Southwestern Louisiana.
Thank you. And thank Bessie and everyone for staying to listen. I know it's late in the afternoon. I want to also mention that these slides were put together by Steve Borenkamp. He works at Wild Well, and he is our General Manager of Training. History's repeating itself. You know, there was a recent piece written by Derek Park, which illustrated those who can't remember the past are doomed to repeat it. There's been several incidents in the oil industry, the CGM North Sea, the Alexander Kirkland, the Ocean Ranger, the Piper Alpha, Petrobras P-36. In all of these, approximately 411 lives have been lost collectively by these accidents. And granted, this is offshore and heavily regulated. So the question comes to mind, are we living with acceptable risk even under these regulations? U.S. domestic land events. This is a listing of domestic land events that go back as far as 1997. Some have lives lost, almost all of them have personnel injured. Well control call-outs. Wild Well Control gets 5 to 7 calls a week worldwide. Of the current ones, 70% are land-based. The majority of the wells drilled in the U.S. are as well. We have 55,000 plus wells drilled this last year, and that's 2011 in the U.S. And on our statistics, 1 per 1,000 will end up being a full blowout. There are over 600,000 production wells that are actively being worked over. Of those, 85% of the blowouts in the last 10 years have been due to lack of fundamental well control, forgetting the basics. our challenge is to respond to the need for a proper process for assessment, for kick identification with inexperienced and experienced crews. Fast drilling, horizontal conditions, and complex fluids mask the changes in downhole dynamics that can be missed or at least misdiagnosed. Land drilling doesn't always face the same requirements from a regulatory basis that the offshore drilling does. And we need to explore ways to increase the operational well site awareness and good communications to add to our safety and efficiency when formal training doesn't alone isn't enough. Well site competency drills and assessment drills, rig audits, random testing with gap analysis, incident command coaching drills, and DWOP drills. The visible safety leadership from our senior players, whether it's operator or the contractors in the industry, are inconsistent. Workers do not believe it to be a high priority that duty holders claim to be, stop actions or shut-ins. Technical issues can be solved by design, but behavioral issues require a little more attention. Individuals must have confidence and authority to do the right thing within the work environment and at the right time, their job integrity. If we don't empower and support the employees to react properly, then we are condemned to future incidents. Well-controlled training, IADC, API, IWCF, is generally recertified every 2 years, and many crews forget they experienced what they experienced just 6 months later, sometimes less. Internally, we've done audits and testing on our own people, and at a 1-year interval. And I will tell you that most of them flunked the same test that they passed the year before. One effective way to add importance to what is expected at the rig site and give confidence to the crew is offering well-controlled tune-up, measured kick drills, training specific to each job responsibility, frequency. Many employees have never even heard about well control and what to even look for until they reach the AD level, so additional awareness is useful and profitable. Insurance companies have supported well-controlled training for many years to reduce their losses. Generally, the clients have only one supervisor per site to be compliant. Is the rig manager the only one that needs awareness here offshore? Is it the AD? It's the AD and above. Can drillers see all that goes on? If the hands are well informed, will they do what is needed? And if they don't know, then self-preservation will definitely take over. Can they really create a stop action? Saying it's so isn't practicing it. There's a disconnect. And the problems we face together, in the rush to field new rigs and new crews on an ever-increasing scale, we place hands with little education and illiteracy with the systems that they're operating in multiple languages and expect understanding on engineering technical type principles. Tick and flick expectations and training still exist. Too high a rate of consultants with poor skills. A 9 out of 10 mentality. No problem, it's just shale drilling. We've done this before. Work over drilling experiences. Why not incorporate skills and well-controlled awareness where they operate in a practical sense? Non-threatening environment, supportive, real-world practices, job-specific, and well-specific. Well site expectations, to give an evaluation of crew effectiveness to react to potentials of a kick. Judge the skill sets per crew member. Re-emphasize knowledge of warning signs. A fair gap analysis to apply necessary improvements for managers. Non-judgmental conditions toward crews. A suggested path forward. Meet and greet with the command and RM tool pusher. Walk through a typical well site toolbox safety meeting. Challenge each position about well control responsibilities. Define actions before and during a kick. Execute a kick drill for timing and effectiveness with remediation. Leave and review laminated kill sheets, shut-in procedures, crew responsibilities, written report on effectiveness and potential for additional support and training per employee. Elements of the well site assessment. Train the trainers for incorporation of company's best practices, mentoring. Challenge employee on his duties before and after a kick is detected. Challenge each job position, why his input is critical to the overall operation. Challenge each employee on operational equipment and maintenance necessary for containment. Time their drills for efficiency. Confirm that the driller completely understands his role for shutting in the well. Challenge supervisors. Test critical positions and report gap analysis findings for improvements to act upon, and incorporate frequency relative to operations, biannual or quarterly, if necessary. Cost versus benefits. Low cost, it's easier to move one assessor from your company out to a rig than 4 employees. It's much cheaper than day rate loss or worse. Discounts on BOP insurance or even secondary. Employees' day is more than a rub and scrub. And a team building learns efficiency and awareness. It improves client and contractor relationships, and is compliant with Subpart O and SIMS. Good tools are still good tools. Using the tools that we as an industry have found to be effective, we can eliminate unnecessary loss of life and property. That's good stewardship. It's a good business tool, so we can, yes we can. We can learn from our past and do it better, and hopefully, by design, not being doomed to repeat it. One thing we recommend is drill, drill, drill. Drill your people, drill them in their positions, and drill them often. I'd be happy to answer any questions anybody has.
Thank you, Ken. Thank you, Joe. Our last speaker is Ken DePaul. Ken works in the position of Well Delivery Manager for Shell International E&P based in Houston. He has 32 years in the industry, including 25 years with Shell, and including over 25 years experience in deepwater well engineering and supervision for domestic and international projects. His experience includes deepwater exploratory well drilling and execution, deepwater field development, planning and execution, rig construction and commissioning support, and technology development and implementation. Ken?
Okay, thank you, Mark. And then on behalf of Shell, I'd like to thank the BSEE and the committee for the opportunity to talk to you a bit. I think we've heard quite a few topics and good information today so far. A lot of it has been focused around BOPs, well control training. I heard a little bit in session 1 this morning of a mention around integrity of operations or the whole system. I'm going to take a little bit of a broader view in this session and talk about the focus of well integrity overall, because we see that well control and well control training is just one part of ensuring overall well integrity to prevent incidents. And the theme here is making wells safer and a systematic approach to wells process safety. Okay, so what is process safety? This developed quite a bit on the downstream side as a consequence of a number of incidents in refineries and chemical plants. But simply, process safety means the management of hazards that can give rise to major accidents involving release of potentially dangerous materials, release of energy such as fire or explosion, or both. So how does this apply to wells? If we look at the big triangle, sort of to the left is an inner triangle, which is the traditional personal safety systems that we're all familiar with. And we have fairly established metrics in a number of areas, things like measuring and monitoring first aid cases, unsafe acts and conditions at the bottom, and then escalating to more severe incidents as it goes towards the top of the triangle, which in a personal safety case is a fatality or a multiple fatality case. We're taking a similar approach towards a process safety side, that we are tracking similar incidents, and at the bottom, it again is things like unsafe act and conditions. As we move further up the triangle, then there are items such as the loss of a single barrier in a well, where you would normally have 2 barriers, then the loss of 1 barrier reduces the overall integrity of the system, up through more severe cases of loss of containment of the well, uncontrolled release of substances, and then a major catastrophic event such as the blowout. And then just as a comment from the presentation before, I thought the statistics were quite sobering in that as an industry, we're still seeing, 1 in every 1,000 wells where there's a blowout that's experienced. Okay, so what we're trying to achieve is overall wellbore integrity. And so this is a systematic approach to the wells design and execution process to get us there. We see that well control and well control training is one aspect, but there are quite a few pieces to this puzzle to get us where we need to be. First is design integrity, and in order to achieve that, we have a series of design standards within the company. Second is technical integrity, and that allows us to manage the technical risk and the construction risk. Examples of that are things like our well control manual, HSE case on the rig. And then there's operating integrity, where we have things like an HSE case on the rig and a safety management system of our own, and then generally in conjunction with the contractors that are also doing the work. And overriding all this is we need to have competent people involved in each of these aspects, and that includes not only well control and well control training, but competent people for the design of the wells and the operation of the wells. Okay, I think we've seen a example of a bow tie that was given by DNV in one of the earlier presentations. So in wells, we're using a version of a process safety bow tie. I guess the top event or an incident is shown as a circle in the middle of the bow tie. On the left side, think of it as controls to prevent that event from happening, and on the right side are measures for recovery or mitigating the consequences. So we focus on both areas. On the left side, the items include standards for overall well design, overall well control manual, rig safety cases. On the personnel side, we have technical competence testing, and I'll show a little bit about that, a little more about that in a couple slides. We have technical authorities and a assurance framework in place. We have a number of what we call principal technical experts in the company to provide support and advice across the board. We do have tests for testing competency of contractors, various items on equipment and measuring status of systems. On the recovery side or mitigating consequences, standards include requirements for well designs to allow the ability to cap and contain the well in a worst case scenario. Again, our well control manual, we have an incident response or blowout containment plan. And on the equipment side, we do have equipment that has been developed both internally and within the industry for things such as spill containment and capping systems. All right. Some of the examples of standards and processes that we have within the company are an overall global wells management system manual. So in some areas, we are legislated by requirements for what we need to do. In other areas, we are not as legislated, but we do have overall global requirements for how we manage the entire wells design and execution process. We have a series of an engineering manuals, a set of what we call DEMs. We have a system in place for monitoring, tracking, and reviewing what we're calling process safety incidents, which is in addition to the personal safety system and statistics that we monitor. We also have a electronic well control assurance tool. It's similar in some respects to some of the systems that were shown earlier. However, it does not include the detailed BOP health check type monitoring system. But the electronic well control assurance is a database that records compliance of equipment and certificates of conformance for equipment, records certification of personnel, primarily well control certification of required personnel. It also includes a record of well control equipment testing, both function testing and BOP pressure testing, and there is a barrier verification and assessment recording, whereas we have a barrier plan, and then the verification of those barriers is also included in the system, and that may include pressure testing of casing, for example, or confirming the amount of cement that was used is the same as per plan. And then we have a management of change process with respect to wells activities. Okay, on the training side, we have a couple different systems. In wells, we have what's called a competency development program. This was started as early as 1973, and in Shell's terms, it's called Round 1 and Round 2. So it's normally a multi-year effort to get through the program, which includes exams and certifications. On average, there's an 80% pass rate of personnel through that system that has been implemented globally for all Shell well staff. It includes both practical and office elements, and you can see in the picture it's a fairly substantial paper package of binders to get through. In order to continue as part of the wells discipline in the group, each engineer must pass both the Round 1, Round 2 exams and become, quote, certified. It has been accredited as the equivalent of a Master's of Science degrees by 2 universities in Europe. Okay. We also have some other expertise in competency testing. We have what's termed a Round 2 diploma for some of the more experienced and operating staff that did not come through the company with a university degree, which is basically a reduced version of the Round 1 and Round 2 material. For consultants that we use for supervision on site, they are required to take a trade test before going out to supervise operations. We've developed our own advanced well control course with our own simulator, and that is, as of this year, that will be mandatory to be done every 2 years for operations staff. For contractor competency, we require either well cap or international well control. All right. Okay. Quickly, we do use the HSE case system globally and have done that for a number of years. You see the bow tie on top, and then the what's normally called the Swiss cheese model on bottom. And so again, on the left side is prevention, on the right side is recovery, and we want to make sure we have strong systems in place basically to reduce the size of the holes in the Swiss cheese to ensure that we have better competence to prevent the top event or the blowout from occurring. So, and again, that whole system is only effective if people understand their roles in the critical activities. So HSE case generally includes a risk assessment matrix, which is shown on the bottom, and it is conducted in conjunction with the drilling contractor normally. So there is an interface or bridging document that's required between ourselves and the respective company, and these are consistent with the SEMS requirements that have recently come out. And then on the far right side of the bow tie, we have a emergency response system in place that includes blowout contingency plans, which has two elements. One is relief well contingency plans, and then secondly is a capping plan. What's shown on the right is a photo of a capping stack. This is actually the MWCC single ram capping stack for Gulf of Mexico. Shell is a member of that, along with a number of other companies. Globally, we're also participating in the OGP or SWRP effort. And then also we have two capping stacks that Shell owns available for global use also. All right. So in summary, it's more than just well control and well control training. We have across the board a systematic approach for wellbore integrity that includes design, technical, and operations. And then competency of personnel is required throughout all phases to ensure that we do have adequate wellbore integrity. Thanks.
Thank you, Ken. With that, I'd like to open it to the floor for questions for any of the panelists.
Hear me or now you
Yeah.
can. Got it. So a question for Ford and a question for Ken. So Ford, in your presentation on training, you cited the professional engineering qualification for the engineering staff, and Ken just presented maybe an alternate model whereby it's a certification of the engineers. If you look at the professional engineering standards, the one for petroleum engineering is mostly applicable to drilling, but drilling is a minor part of that. It's really dominated by reservoir and the other disciplines in petroleum. So when it comes to really engineering certification to address the risks we face in well design and operations, I contend that maybe that is not the model we ought to follow, and maybe something that Ken proposed would be more suited. Your thoughts?
Yeah, my presentation is confusing if it meant to say that, oh, I'm a professional engineer, which, by the way, I am, means I can do any kind of engineering, or, in my opinion, that this is a floor to the competency situation, which is professional engineer means that you can kind of solve complicated problems that involve math, is basically what it certifies. It doesn't certify you know anything about blowout prevention. It doesn't certify you know anything about what you need to do your job. And so what wasn't maybe clear enough in my presentation was that these competencies that will need to be assessed and certified are related to roles and job specific, which is this would be an exact example of that kind of thing. And so that the certification for a professional engineer, it will not be sufficient to ensure that we have capable people who can engineer these wells. And that's one role, by the way. There's a subsea engineer. There's dozens of other roles. And so if it came across as, oh, all we need to do is get professional engineers, everything's cool, that's not what I believe.
Okay. Yeah, Joe, I think you bring up a good point. You know, the PE certification can apply to things like mechanical engineering, civil engineering. There is one for petroleum engineering, as you mentioned, that is quite a bit focused on reservoir engineering. And I think as a company, we recognize for many years that wells for drilling and completion probably did not exactly fit one of those specific PE tests. So I think that's why we've had for years our own, basically wells training course to get, even though they're not certified as PEs, they're at least trained to the equivalent level that we think we need well engineers to be trained for to do well designs to meet standards.
Ricky Cummings here. I'm the co-chair for Standard 53, working with Frank. A question about a lot of discussion today that I've heard as far as training on how to detect a kick, how to, before it happens, before we end up having a blowout, but not a lot of discussion, which I think is the right way to go and very important, but also equally important is on the maintenance. Who's maintaining BOPs? Who's doing the maintenance on it? There's the OEMs put out torque values, they put out proper lubricants, and I think these guys need to be trained to understand those reasons, why they're putting them on there. Mostly it's roughnecks, roustabouts moving up to a subsea engineer position, and no accreditation or any kind of course or training in hydraulics or electronics that these systems use. And I guess this specifically to Mark, because you did mention it briefly about subsea training and accreditation, but is any of the panelists aware of any industry movement towards certifying these guys that are working on the BOPs?
Well, WellCap in general doesn't address the technical side of training, it's more well control. But I think that in general, well control has to be from the time as well is planned till the time you P&A the well. Well control shouldn't imply just what do you do when things go south on you. You should be planning the well so that it's a non-event, start to finish. I'm not aware of any programs right now other than the manufacturers who are providing that training. There are a lot of, I don't know if you call them certificate level, but they do have training that rig-based people can be sent to currently to learn the equipment, learn how to properly maintain it, lubricate it, work with it. It's all available, and I know the major contractors do utilize that service extensively, especially offshore. People work offshore, send people to the manufacturers for that sort of training. What we're hoping to do moving forward is to develop some sort of a certificate program that goes into a lot more depth about the day-to-day operations of the BOPs, but it's a work in progress. So.
Yeah, I'm not aware yet of any formal certification that's required for someone to be titled as a subsea engineer to do BOP work and maintenance. I believe it's at the contractor-specific level to determine that and where they are for ensuring that those people are competent to do both the initial review of the BOP system and then any subsequent maintenance. But I guess I'd open that up to one of the drilling contractors that are in the room to see if they have an opinion on that.
One thing I like to add, it's pretty common practice nowadays for contractors to have their subsea engineers live with that BOP from the time it's being built, the entire time it's being built at the manufacturer. So typically they know that piece of equipment inside out, and that's a very common practice now. But I agree, there is no defined certificate program at this time.
Daryl Brister with Petrofac Training. Mark, you and we said on IADC when we were you talked about the skills, knowledge, ability, competency framework and stuff that was being built. And obviously here in the States, we need to do a better job of understanding that training doesn't equal competence. So my question is around the integrity of any competence assurance system is going to be around its assessors. So how do we qualify people, subject matter experts, to assess or even certify these assessors? Behavioral analysis shows us that what we can't do is allow a supervisor or a peer to go out and do that assessment. because we would rather coach them than actually follow the standard. So there's legal implications there for all of us, right? Because if I sign an individual off as being competent or not yet competent, I have to measure it against that standard, whatever it may be. So as Kim was talking about from a process safety standpoint, we start thinking about how we're going to assess people on the well, understanding the integrity of the well, the barriers, the controls, and all these type things. So we have to have independent assessments that's there. So I guess the question is more around, what are we going to do to ensure the independence of assessment to deem somebody competent or not yet competent? And how do we either qualify these people through an internal system like Shell's, for example, or externally certification that's out there?
Well, any competency assessment program, no matter how well it's written, is only as good as the assessor himself. And typically those assessors are the supervisors on the rigs. I have been involved in writing a very successful competency program, but it was successful only because we took the effort to get out in front of every single employee one-on-one to teach them leadership, mentoring, assessing, and to teach them the importance of the decisions they make in that assessment process. They don't pass a guy through simply because he's their cousin. What's the impact of that guy negatively and positively, but the negative impact on the program overall. So it's another thing that we're seriously talking about, is trying to create a formalized assessment training program that we can roll out and help companies with. But I think there's quite a few out there that already do this. They go to great lengths to try and coach their assessors. And it kind of comes down to the culture on the rigs and in companies in general. If people truly believe that what they're doing is right, they'll do the right thing rather than take the shortcut and improperly assess people and push them through to promotions they're not ready for. But if a program's written properly and the people are trained, it'll work.
An assessment is like an audit. It's a competency audit. And of course, I have a little company and I like to have external auditors come up and check on my accountants every now and then to make sure things are going right, because you want to make sure that there's an integrity in the system. If the system is designed properly, though, and in the competency condition, it is actually making it so that you describe the task, the condition, and the standard necessary to perform the activity. It is clear as to what is required, and then there's a description of the competencies required for the assessor. Similarly to, analogously to a description of what's required to be a CPA to come in and audit my company. And so it folds back on itself in the sense that there's competencies required to be assessors, and they are tractable, definable things. Not to say that any one of these descriptions will ever be perfect. The competency description will never be perfect. There'll be a hole in what the assessor's knowledge is or whatever, but a proper system will be self-correcting and will be continuously maintain gains and continuously improve it as you move forward.
At IADC, we do have a competency assurance accreditation that we offer to companies, and one of the key components is that you have a process for training your assessors and tracking your assessors. So it's a key component.
I have a question for Don Winter. You won't let you off easy here. You mentioned SubSafe, and certainly your knowledge of SubSafe and also your involvement in the review of Deepwater Horizon. So there are a lot of positive things, and I've been looking more and more at SubSafe, but from your perspective, what would be challenges applying SubSafe, the nuclear Navy's doing, to the private world of contract drilling and operations?
I think the SubSafe program has been particularly effective for two reasons. One aspect should be pretty easy to apply, one aspect is going to be difficult. The easy aspect is that SubSafe focuses just on two fundamental concerns associated with submarine operation. Can a submarine submerge to depth without being crushed? And when it's submerged, can it resurface? That's it. A lot of other safety issues on board a submarine, fire and all sorts of electrical problems, things of that nature, they're outside the scope of SubSafe. It really focuses on those two core issues. The other, and I think that aspect is applicable to industry, that's applicable to this industry. It really, it's not a problem there. The one other aspect that the Navy employs, which I don't see in the industry, is a very strict sense of personal responsibility and accountability. People are removed all the time. I used to do it. And people would say on many occasions, well, that isn't fair for that one individual. There are extenuating circumstances, or there's this issue or that issue. It didn't matter. What we were concerned about was not what was fair for the individual, but what was fair for the service, for the Navy. And establishing the expectation that everyone had to do whatever was needed to operate in a proper manner did more to focus the efforts of individuals, and a lot of this has to do with individual focus, than anything else. And so, yes, every once in a while people would say that was not fair, and I might even agree that there were certain unfair elements. But if it was really, if it was in the best interest of the Navy, that's what you did. I worry whether or not the legal system in the United States, having spent a good bit of time also in private industry and having more than my share of wrongful discharge litigation, whether or not it will put up with that type of aspect. I think it's going to require some very careful drafting of any similar procedures to ensure that you can, in fact, take appropriate action in a timely manner and ensure that the needs of safe operation take principal priority.
To that point that you were just making, have there been any efforts, and this is a panel question, have there been any efforts or initiative requested for soft skills along with technical skills that are being trained in the field? Of course, the soft skills, speaking from yesterday and today, when my mentors trained me, they trained me to go to work on a piece of equipment, but when I was on my way to that piece of equipment, I would touch 9 or 10 other pieces of equipment, and I would come up with more preventative maintenance or corrective maintenance just going out to do 1 p.m. Today, because of the younger and younger workforce, they're generally taking that PM right off of a printer or away from their supervisor. They go straight to a task and they come straight back, and the preemptive action of actually inspecting our equipment is starting to fade away. I'm starting to see this in a lot of different of the technical aspects within our industry. And of course, our company has been asked many times to do assessments on not just the technical side of any one discipline, but also the soft skills. So I was just wondering if you guys have had the same experience where you're starting to get requests to change the way people think about the way that they do their job.
Yeah, this is my experience. People recognize the importance of soft skills, and so, you know, teamwork's important, communication's important, emergency response, personal behaviors are important. So it's not that, oh, we don't care about that. My experience, though, in attempting to come up with common competency standards, you can generally get people to kind of come around technical standards and start talking about casing or mud or whatever you're talking about and get people to agree to that. The issue we have with soft skills is coming up with a common standard or taxonomy, and so it's very often that people don't even use the same word to describe the same thing. And so in other words, one of the difficulties we're going to have is we all talk about mud weight, we all weigh it the same, we use the little same thing, and so we talk about it, we got that one sussed out. When you're talking about what are the roles for the company man, what are they, and do we describe them the same way? And a small analogy to that, coming back to the personal safety thing on Ken's pyramid, for example, is that, you know, people said, oh, we don't use stop cards because we didn't want to license them from DuPont, but we call it something else. But, you know, and you're not be able to have people go from one operation to the next if they're not calling things the same. And so the challenge in the soft skills is not that people don't think it's important, but coming up with kind of a common set of standards about what we're going to do and what a role is called, and getting agreement on what is required for proper communication, and defining that and creating standards as compared to should be able to recognize a kick and calculate the mud weight. And so that's my personal experience. We have a bit of difficulty in coming with a common set of approaches for the soft skills.
I think you'll find that most contractors out there, at least, and I'm sure the operators as well, have pretty robust onboarding processes and whatnot to teach a lot of those soft skills. But I agree that there is probably a disconnect between company to company, so that it is tough to transfer people in between different companies. And I think the big goal is to try and find that commonality to be able to transfer people around. So.
Any other questions? Okay. Well, if not, then thank you for participating in this panel. And I guess we'll turn it back over.